Nothing significantly important. It's the first octet we're always going to be concerned about, not the fourth one. So that's basically how the 32 bits are divided in 4 groups of 8. Now the other thing, as we go through IP addressing and subnetting, start taking mental notes of patterns. There are a lot of patterns. As soon as you are able to identify patterns, IP addressing is super easy. Okay. So we're not dealing with just 32 bits. We're only dealing basically with groups of 8. Period. Which means that what? We have 2 to the power 8, 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 right? Which is basically what? Which is 256. Okay. All right, so 256. That basically gives us a range from 0 to 255. So that's why I'm going to sound like a Taylor Swift song. You'll never, never, ever, ever, never, ever have a number greater than 255. It's impossible. Okay? So that's how the numbers are broken down. So we're kind of down like just a little bit. Get it? A little bit. So when we multiply all these numbers out, what do we get? 256 times 256 times 256 times 256. That is a nice little number, such as 4,294,967,296. You're not going to get quizzed on the actual number. It's going to be approximately 4 billion, that's a B, 4 billion what? 4 billion combinations of IP numbers. Now, that sounds like a lot, but it's not. We would have ran out of IP addresses, pay attention, we would have ran out of IP addresses a long time ago. But with a service, we're going to talk about this in networking here, but with a service called NAT, N-A-T, Network Address Translation, that basically conserved a lot of IP addresses. And this is where the private IP addressing comes along. So we'll explain that more as we continue on. But again, this is kind of how things are set up.
Forgive me. I know you're in the midst of explaining, but I have to go use the bathroom.
No problem. So, before I get into the whole details of how IP addressing works, let's do something concrete, like a building. Concrete, steel, doesn't really matter, you know. This will give us basically the foundation that you need to kind of help you mentally visualize of how things are set up. So let's take a look at the buildings and the relationships about the buildings here. So we have, let's say, 3 different categories of buildings: skyscraper, high-rises, and office complexes. Now, without utilizing a number, we're just going to basically utilize words. How many skyscrapers are there compared to a high-rise and an office complex? When it comes down to that. What about a high-rise? What do we got in a high-rise? A bit more? Got it? A bit more? All right, we're talking about binary, a bit more. What about office complexes? How many office complexes are there? There are lots and lots and lots of office complexes that are out there. Right. Kind of makes sense, right? Or it should make sense. All right, now let's look at the relationship from a building. So a single building, how many rooms does a skyscraper have? Got lots of rooms. Yeah, we're just utilizing just a regular word. What about high-rise? Obviously, there's a pattern here. A bit less, right? What about office complex? Yeah, very little, right? Or few. Okay. So the whole idea here is understanding that you're able to visualize a building. Sears Tower. Okay. I don't care what they call it now. It's always the Sears Tower. Born and raised here, so it's always been the Sears Tower. So the Sears Tower basically is going to have a lot of rooms, a lot of square feet when it comes down to it. So when we start changing things around a little bit, you need to. So when lingo gets changed to networking, you know what we're talking about here. All right. Now the reason I have this is because what are the two parts of a network? Or what were two parts of an IP address, should I say? So we have a host and the network portion of it. Okay. Now it does matter which one comes first. So over here, it doesn't matter if it's basically if I'm saying rooms or building first or building and rooms. Clearly, it makes a difference because we first need to identify the building and then the room. You go on vacation, you go to a large hotel. My room number is 456. Was that helpful? No, I mean, you need to know the building first before you go and get to the room. Makes sense? Same thing in IP addressing. So the analogy here is the number of buildings over here. This is going to be referring to the network. And the number of rooms is going to be referring to what? Got it. The host. Okay, so those are two portions associated with it. Make sense? Easy peasy. It's not that difficult. Now, I have another column for IP addresses. So kind of like smashing in the networking portion of it. So clearly we identified that there are how many classes of IP addresses? Total of 5, but we only used the first 3. So how do you think the IP addresses are going to correlate back to this model here? Skyscrapers will be a category of A, B, and C. No surprises. I'm telling you, this stuff is easy. Stuff is easy. Cool. Now, let's toss a curveball. So let's say that I hired you to document all the buildings worldwide. Boy, that would be a pretty challenge, right? You're going to document all the buildings worldwide. Well, the formatting number is going to be this type of configuration. So, the skyscraper model, we said that there are basically few buildings and lots of rooms, right? So what we're going to do then is we're going to somehow divide the 4-grouping numbering system and utilize the first portion to identify the building and the next 3 to identify the room ID. Kind of makes sense, right? Because if we're talking about the Sears Tower, it's all right, section 4, floor 25, room 2. Right? So obviously we need more positions over here to identify the room. Kind of sort of makes sense? Yes, no. And guess what? There's a pattern to this. So what was our next type of building? The high-rise. So what do you think is going to happen? So we're going to basically kind of like shift over. So meaning we're going to have a configuration such as this. So now we're going to have the first two numbers would identify, right, the building ID. A little bit more granular, we have the city and building, let's say. But it's the building ID, the first two numbers. And then the last two numbers are going to be basically identifying the room ID. Making sense? All right. No surprise here. So what was our last building? The office complex. So what do you think is going to happen there? We have the shift, right? Because we have basically a lot more buildings, so we need to have more numbers identifying the building. And then basically we have one number to identify the room, because we said there are not that many rooms. Making sense? Cool. Love it when things make sense. So again, just reinforcing that these are the different classes with that. So again, the building is going to be your network, right? So when we talk about the network, we're talking about this network here. And room is going to be identified as the host. Easy peasy. Now, I kind of hinted that basically each of the classes, A, B, and C, are going to have their unique range. So we have 1, 2, 3, 4, right? So the first octet, right? The first octet, when you look at the first number, that first number is always going to be identifying the class, right? Because once we established these numbers and that, so we're always looking at the first number and it's always going to identify the class. So that means we need to know binary. Right. I think you have this, right? I drew a picture on that front. Okay. So now we need to basically get the binary values here. So 2 to the power 0 is what? 1. 2 to the power 1 is 2. 2 to the power 3. 4. 2 to the power 3. 8, right? Let's go. 16. 32. 64. And a whopping 128. Okay, so this is basically, so in the book, it basically identifies the ranges. I gave you a quiz on the ranges and that, but how did they derive? How did they just pick things out of the air? No. So this is how things work. This is basically the highest ordered bit, and this would be the lowest ordered bit. Obviously 2 to the power 0 to the power 7, right? So when I say highest order bit, we're talking about that end. We have a class A, and you can see there's going to be some patterns here. So the highest ordered bit here, this must be a 0. It's got to be a 0. Okay? So that means that the rest of stuff, so when we start out, we're going to be 0, 0, 0, 0, 0, 0, 0. So what's my value here? So my value is going to be 0. Now eventually, just like on the light switch, we have the different combinations, right? Light switches here. So eventually we'll get through all the different combinations and we'll get where all these are ones. So what's the sum of those numbers there? What's that? You guys know what I mean by the sum of the numbers? Maybe for you gotta. You can say, hey, what do you mean by sum of the numbers? Ooh, I got a question, right? Well, when I'm talking about sum of the numbers, wherever there's a 1, we need to add that number. So 64 plus 32 plus 16 plus 128 plus 4 plus 2 plus 1. I know, math is hard. And that is, dun dun dun. What's that? Are you sure? You don't sound confident. It's 127. Okay. Again, the patterns. What are we doing? We're pushing the zeros. So now this is going to be a 1 and a 0, 1 and a 0. So that means, again, we're starting off with zeros. So what's my sum of the numbers here? What's that? Well, it should be 128, because what comes after 127? 128. I mean, let's see, because we get here. That's 128, right? 128. And then eventually we get to where we have all ones, right? So what's my sum here? What was that? 191. Someone's good in math or remembered what the range was. And guess what we're doing with the zeros? We're pushing them again. So it's going to be, what's my series over here for Class C? What are the first 3 octets or 3 digits? 110, 110. So then once again we have 0, 0, 0, 0, 0, which gives us a number of, well, if you are able to do this right, 192, because 128 plus 64 is 192, and clearly after 191 is 192. I'm kind of doing this in order. And then we get to the point where we get 1, 1, 1, 1, 1, which is what? 2, 2, and 3. Yes? Yes, yes, yes. Yes. Sweet. Okay. So basically, these are our ranges for Class A, Class B, and Class C. Well, technically not. Because have you ever seen a street address of 0 Main Street? I haven't. So technically your range starts with 1. So from 1 to 127, I think we had a quiz question on that, right? Any questions? No? All working nice? Cool. Oh, let's see. So obviously we see a little pattern here. Okay. Now, for the exam and tests and stuff like that, you need to know these ranges, especially if you're going to get into, networking. You want to see an easier way to come up with these numbers, to figure out the ranges. I mean, I know it's hard to remember the ranges, but how about if we just remember just something very, very easy so we're able to establish the ranges? Good? Okay. But I want you to, before I go any further, in a class A, where is the 0 under? In a class A, where's the 0 under? 128. Class B, where's the 0 under? 64. In class C, where's the 0 under? 32. This is awesome because there's patterns. Binary just works so cool. Keep those numbers, 128, 64, 32. Right? What was the largest number that we could have? 255. In the class A, where was the 0 under? Minus 128. In the class B, where was the 0 under? Minus 64. In the class C, where was the 0 under? Minus 32. So 128 from 255. Use your math. Which is? Strangely enough, 127. 255 minus 64? 191. 255 minus 32? 226? What?
I thought it was 23, but it might be 6.
I'm gonna have to get the preschoolers to come over here. All right, 223. Okay, so what did we accomplish here? So basically, we have 1 to 127. What's after 127? 128 to 191. What's after 191? 192 to 223. Are those the ranges? Go Power Rangers, or go IP Rangers. Ooh, I just came up with something clever. I could do IP Rangers. Yeah, I'm a class A. I'm a class B. Oh boy, I love it. So this is the easiest way to basically figure out how the ranges work. I mean, again, there's nothing arbitrary of how IP addressing works. There's a method to the madness, and once you start seeing the patterns, it's not difficult at all. Okay. So we're halfway there. Wow. Not even a quarter there, but we're getting there. So let me draw up my little picture here. So we have the first octet, we have the second octet, the third octet, and then we have the fourth octet here. And then basically establish that we have the A, B, and C. So what I'm basically looking at distinguishing here, so from the previous building model, we had identified that the first octet is going to be identifying the network portion of it, and the last three are going to be identifying what? Right, the host, and host. Right. So this is basically, the little chart at the bottom that I'm working on here. So then in a class B, we said the first two octets are network, and then we have host and host, right? And in class C, no surprise, again, the patterns that we have here, we're going to have net, followed by the host. No surprise there, right? Okay. So clearly we have a kind of a pattern associated here that we're identifying. But we always look at the first octet for the ranges. So class A has a range of, once again, 1 to 127. Class B, 128 to 191, and then 192 all the way up to 223, right? So those are the ranges for that part. Very cool. So with IPv4, we have the IP address followed by a subnet mask. So there are basically two numbers that are always identified with IPv4. Subnet mask. A lot of people did not know what the subnet mask purpose was. And what I'm about to show you is going to be like, well, this is kind of redundant. I go, yeah, initially it's going to be redundant, but there is going to be uniqueness as we move forward here. The subnet mask is there to identify the network portion of the IP address. So once again, the subnet mask is there to identify the network portion of the IP address. Remember, IP address, we're going to have the network followed by the host. And we have basically 1, 2, 3, 4 octets. So we got to figure out what portion is what. And this is also important to comprehend here. Every class, A, B, and C, will have its own default subnet mask. Every class is going to have its own default subnet mask. So does that mean that the class needs to use the default? Well, no. And that's where things get interesting. But first we need to lay down the foundation of what the default subnet mask is going to be. So for each of the classes here, going back to this particular table, and once again, there are patterns associated with this. So the subnet mask for a class A is going to be what? Subnet mask for class A is going to be what? .255 dot what? 0.0.0. Those are ugly fives, huh? I don't know what I was drawing on that one here. So clearly there's a pattern. What is going to be class B, the default subnet mask? 255.255.0. Whoa. Undo that. 0.0. Can't fool you guys twice. So what's a class C? Yeah, 255.255.255.0. Easy peasy, right? So again, the subnet mask is there to identify the network portion. Each of the classes is going to have its own default subnet mask. So again, for Class A, it's 255.0.00. Class B, 255.255.0. 255.255.0 for Class C. Make sense? Easy. All right, IP addressing is easy, right? Cool. Now, how do we get basically 255? What's the binary value for 255? So you're able to reference your table there. So we have basically what? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7, right? So we got 1, 2, 4, 8, 16, 32, 64, and 128. So how do we get 255?
Is it all ones?
These are going to be all ones. Because 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 255. Right? Ready for the aha moment? Yes. So that one question, how many bits does 255 identify for the subnet mask for Class C? Remember that one question in Kahoot? All right, which almost everyone got wrong. Okay, I'll show you why now the correct answer is. So going back over here, so in a Class A, how many 250 or how many ones are there? How many ones? What's that? So in 255, how many in the Class A for the subnet mask, how many ones are displayed? All right. So we have basically this. We have 255 here, so we have that there. So that means that here we have 1, 2, 3, 4, 5, 6, 7, 8. So how many ones do we have? /8. All right. One more time. A pattern is coming here. So how many ones do we have in a Class B? We got 1, 2. Well, that's too big, huh? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many ones are there? /16. Alrighty, in a Class C, /24. Because we got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8, or 8 plus 8 plus 8. That is 24. Make sense? Okay. Now, the reason I have this because there are basically two ways to identify the subnet mask. The long way, 255.0.0.0, or the short way, /8/16/24. And this is basically what they refer to as CIDR notation. SIDR, CIDR notation. So that's CIDR notation. Any questions thus far? Easy peasy? Not that hard, huh? So again, the subnet mask is able to be identified in two methods. The long way of identifying all 4 numbers, or the short way. Now, someone is thinking, I know this because I'm thinking telepathically with some of you, can we have like a number 9 or 18? I know someone was thinking that. And the answer is yes, we can. But that changes the ball game. That's where we get into the whole subnetting part. Okay. That I got a table for next class. But yes. Now, what time we get off? Now, the way the subnet works is this. You know, how can we have like 8 or 18 or 9? And is there a limit? Well, yes. I mean, there's going to be limits eventually to that part. But here's another critical thing to remember. The subnet mask, because if we write everything out in binary, the subnet mask starts with consecutive ones and ends in consecutive zeros. Okay? So the subnet mask starts with consecutive ones and ends in consecutive zeros. Now, if the subnet mask starts with consecutive ones and ends in consecutive zeros, that means there's going to be certain allowed numbers for the subnet mask. I know someone was thinking about that. We'll get to those numbers next class, because there's some more deciphering we need to do on this whole component then. Any questions? Easy peasy. Yes?
I know you said we wouldn't focus on it, but how would a Class E be displayed? Class D, I would like to say, goes to 32.
All right, good question. So basically, Class D and E are excluded from this. They don't utilize that. So a Class D is utilized for what we call a multicast. Class E is basically used for experimental use. So out of that 4 billion numbers, 4 billion combinations, some of it is going to be excluded because a Class E, we don't utilize those. A Class D, they're utilized in multicast, but very rarely used with that part. So that means we're down to a certain number of combinations of IP numbers that can be used. Okay. All right, so next class we're going to be picking up more on this topic. So again, in Module 3, again, it's a very concise summary of IP addressing and subnetting. I mean, I got to go back and reference it and see now if this portion of it makes sense. The subnetting part is probably not going to make sense until we break things down. I'm going to try to create some additional videos over the weekend, and hopefully I'll get them all published before next week to get some more filler information in. So you see the progress of how things are broken down. So I'm breaking things down very, very granular when it comes down to that. Okay?